So, very good afternoon to one and all. So, we are ready with the second session of one day national webinar on machine learning, introduction and application. So, this is our second session, and it's my privilege to introduce the resource person with us. Akanksha ma'am is with us. Akanksha ma'am, can you hear us?
Um, yeah, hi Shubham. This is Akanksha here. Am I
So
audible?
it's my privilege to introduce ma'am to all the participants. Akanksha ma'am, she is currently working as a consultant with Verizon and has expertise in anomaly detection. She is pursuing her PhD in cognitive sciences and machine learning from PS University Bangalore. She has research experience with the Center of Excellence Laboratories in Computer Science and as a Center of Knowledge Analytics and Ontological Engineering, funded by World Bank. She has data science, machine learning experience in startup industries as well as information security and telecom industries. So it's our privilege on behalf of whole Engineering College Banswara fraternity. We would like to welcome you to give and share your valuable expertise with our participants. Our students and many faculties are also there. So I'm handing over the session to you, ma'am. Please.
Thank you, Shubham. Hi. Uh, I'll start my session. I'll
Yeah,
start
sure. Please,
start
ma'am.
sharing my screen. So hi all of you. How you all are doing? Uh, all right. So I'm just starting. Just give me a moment.
Meanwhile, I request all the participants to just do not share your screen anyhow and keep your mic on mute mode, please. Every participants during the whole session. Thank you.
All right. I hope it is visible to everyone. The screen.
Yeah, ma'am. It's visible. You can go ahead, ma'am.
Okay, hi. Hi, so my name is Akanksha Tushniwal, and today I'm going to give you the introduction about the anomaly detection, which is one application of machine learning technique. So I'm sure that most of you have not heard about the anomaly detection, Um, but at the end of the session, you will know some things about anomaly detection in machine learning techniques. So, again, let's start. So I'll go with these agenda points. So the first one is I'll just give one slide of machine learning introduction and its application. Then I'll go with the machine learning application, which is anomaly detection. Then what is anomaly? What is anomaly detection? How to detect anomaly? How to implement if you are new to machine learning, and how to get started with the machine learning. So I'm assuming that many of you have not yet started machine learning. You are beginner in the machine learning, so we'll have one hands-on session in the end of the presentation one, and then how to get data for machine learning. So I am assuming that most of you don't know how to get the data from online resources, and which data to get for your machine learning practical implementation. So I'll tell about that as well now. And then, last is the working example of anomaly detection using classification model. So this is the agenda for the presentation today. All right. So this is machine learning. So as Priya already told about what is machine learning, I'll just give one line introduction. So she gave one example of how to detect a raw mango and a ripened mango from the box of mangoes. So it is the machine learning is the ability to automatically learn and improve from the experience without being explicitly programmed for each of the entity. Like we are not programming the system for each of the mango. There are a bunch of mangoes, and it is programmed for all of the mangoes together. Okay, then now we have the applications of machine learning. So most of us are using these personal assistant application, which is used in our daily life, which is Cortana. Cortana, if you are not aware of, it is the Nokia personal assistant, um, which was first available in smartphones. Now we all use OK Google assistants, Hey Siri, the Apple assistants, and Alexa. So these all are the applications of machine learning. Then we have traffic predictions. So when we have our Google Maps on, it tells us the ETA when to reach, what is the ETA to reach at any destination from any source in real time. This is one of the application. Then we have social media services. It recommends you whatever you saw in your Instagram or in your Facebook. So this is one of the application. Then we have fraud detection and intruder detection. So basically, these two detections are this fraud and intruders are something which we want to be away from these frauds and intruders, and we want to detect these from the systems. So we'll be discussing about this fraud and intrusion detection in the system, which is also called as anomaly detection. So fraud, as in like the credit card fraud or the insurance fraud. An intruder is any attack or malicious activity on your system or in your network. Then we have video surveillance. So in video surveillance, this is something when there is a user, like there are people on the road, and it detects the crime before the crime happens. So it detects the malicious activity, like the abnormal behavior of the user standing on the road, and then detects the crime before it happens. So this is one example. And then we have this product recommendations, which is basically when we are using any of the application, that Amazon, Flipkart, or Mintra. So it recommends us the products which are most closest to our last purchase or our last search history. Yeah, so this is the basic introduction here. So now let's talk about what is anomaly. So in the first picture, in the dark picture, you can see that like you can easily tell like what is the odd one out. So the main aim of anomaly is to find out what is odd one out. So this could be any type of fraud, intrusion, any attack, or any malicious activity. So now there are three types of anomalies. So one is point anomaly right here. I hope you can see my laser point. Then this is collective anomaly and this is contextual anomaly. So what is the difference between all these type of anomalies? So anomaly, point anomaly is when there is one suspicious activity, there is single activity which is away from all of the normal activities. Corrective anomalies are when so in this ECG diagram we can see that this red is anomaly. But why it is anomaly? Because we can see that this point occurs here and here and here also before and after in the signals, but then we are not calling it as anomaly because it does not happen in the collective manner. It happens only at one moment of the time and then it goes back to different signal. So this is called as collective anomaly. And when we have the contextual anomaly, then what is contextual? So when we say that this is the time of the time all the months in the year, and then we have the temperature. So we can see that here at T1 time the temperature is normal. But at T2 time, we can see a sudden dip and sudden increase in the temperature. So in the June month, this is not what is expected from the system. So here, if we see in the June month, it is a smooth curve here. But when we compare this last June to current June month, the temperature goes sudden down and sudden high peak. So these are anomalies in the system. I would like to add one point here. So if at all I am not audible to you properly, just ping once so that I will be able to know if I'm not audible. So why do we do anomaly detection? Like why do we do anomaly detection? So we have a huge amount of data presented. When there is any particular activity which is fraud, suspicious, malicious activity, or any change in behavior of the any person or any event. Like the best example of anomaly is right now the COVID situation. This is the huge change in behavior in the system, right? So this is odd one out. This is suspicious. This is all anomaly. So we have a huge amount of data available with us, and there are some events which remain unidentified from that huge data. And we want to detect that particular unidentified object which may cause our system in very bad results, we can say. So it doesn't mean that the anomalies are always bad. There are some good anomalies also, but when we look from the business point of view, we always want to find out the odd one out or the suspicious activities in the system. Okay, so I'll give you one example here. Like Priya told in the previous session, she gave the example of this ripe mango and raw mango. So let's say you take one more fruit from the box and it turns out to be apple. Now, all of the features of that apple, the color, the size, the shape, it does not match with the mango. Now, what is that apple is called as? It is called as anomaly here. So, yeah. All right. So, what is anomaly detection now? What is anomaly detection? Okay. So, what do you see in this slide? What do you see here? I'll just give you 5 seconds. All right, I cannot see the messages. Is anyone replying?
Ma'am, please continue. You
No.
are audible.
Okay. Okay. All right. Okay. So what do you see here? So I just wanted to ask this question. All right. So we are seeing here the change in the behavior of the pattern. So what we are looking here is any change in the behavior of the pattern. We are calling it as anomaly here. So in this diagram, in the first diagram, we can see that there is a sudden peak in the time and the value. This value could be anything: temperature, pressure, or any of anything, any continuous variable. Then we have this again time and value, and we see that the behavior is a sinusoidal function, but we see here as the box function here. And here we see that there is sudden peak above threshold. So there is something called threshold. So whenever there is some continuous value which goes above threshold, we call it as anomaly sometimes. And here, what do we see here? These are the simple patterns of the zebra print. Now, when we look at first, second, and third, we see the sudden change in the pattern. So what is anomaly detection here? It is clear to you that anomaly detection is the detection of the deviation of the regular pattern, of anything from regular pattern. Okay. So how to do the anomaly detection? And how anomaly detection is machine learning. So there are some rule-based anomaly detection algorithms as well. But why it is called as machine learning, why it is the application of machine learning. So we use machine learning here to detect these some patterns of behavior in the system. Now, when we have those patterns, we find out that whether those patterns are normal or those patterns are abnormal. When we have the normal or abnormal patterns, so when we find out, we have to find out that what makes the pattern abnormal, and then whether the abnormal pattern is anomaly or not. So here we can see in the right side, we can see that these are the clusters of data points which are different from the blue and orange. So they both are different in the behavior. So these are examples of the clusters, how the clusters are formed. And this diagram right here, x1 and x2, it tells us that any point which is away from the majority of the cluster is called as noise, or in our case, it's anomaly. So these orange points here are noises or anomalies, and the bigger clusters of similar data points are normal data. So whether it is supervised or unsupervised, do we know? Well, we cannot say until we see the data set that it is a supervised or unsupervised. So I'll just give you one example. If you don't know, for the beginners, what is supervised and unsupervised. So here on the left side, we can see that there is a robot and there is a picture. So when the robot says, is it banana? It says no. When it says it is apple, it says yes. So it means that there is a data set which says that when this color, this shape, and this size, then call it as banana or apple. So there is one, imagine that as a table with a column saying that banana or apple. So in supervised learning, we have the data set like this. And in unsupervised learning, we do not have the labels in the data set. So the algorithm has to figure out itself whether it is similar object or it is not not closer to the similar objects. So here we can see that there are bananas and apples, and then it somehow managed to make the clusters. So in unsupervised learning, we use the clustering algorithms because to find out the similar data points and make the clusters of the closest data points. So, how to detect anomaly? Now, uh, when you have the problem statement with you to detect the anomaly, but what data do you use? What what do we do with the data? What do we do with the features? What do we do with the model and so on? So, how do we start with it? So, first of all, in this diagram, we can see that there are some of the algorithms for anomaly detection. So, we can see that there are some classification based um, algorithms. There are some nearest neighbor based algorithms, clustering based, statistical based, and other algorithms. But to reach these algorithms, what do we do first? So, uh, this is the flow of any this is the flow for anomaly detection, but this flow is majorly can be used for any machine learning algorithm. So first we'll go with the data collection. How, where, and what data to collect, and do you really understand your data? So I have made a list from where you can get the data from. So there is some UCI machine learning repository. So I've given the link. Maybe this link will be also be included when the mail or the YouTube link will be uploaded. Then we have the Kaggle datasets. Then we have Amazon datasets, Google datasets search engines, Microsoft datasets, awesome public dataset collection. So this is a GitHub library where you can find different datasets for from public. Then there are government datasets. So government datasets are usually the the rainfall dataset or global terrorism dataset and so on. And we have computer vision datasets. So if you are interested to go with the image processing techniques in machine learning, you can go and get the data from computer vision datasets. And this computer vision datasets will also be available in UCI machine learning repository. And then there's something called Lionbridge AI datasets. So this may be helpful for you guys. Then we have pre-processing. Once we have the data set with us, let's imagine we have the data set of fruits, the mango, the size, the shape, the color of the fruit. Now, there are some fruits, there may be some fruits which does not have some of the features, or let's say the timestamp, there is a timestamp, or leaf. When we say there is a leaf on the top of the fruit, okay. So there, in say when we talk about lychee fruit, there are leaves available, right? But when we talk about apple or some other fruits, when we get the fruit, there are no leaves. Okay, so that leaves column, imagine that it is a null value. So pre-processing is the technique where we want to discard all the null values, discard all the columns which we are not going to use. So catching only the important features or important um, uh, data points which are specific for our problem statement. And then we have to plot some of the distribution plots, the bar plots or the scatter plots, all type of visualization of the data to see whether this is going to be useful for us or not. Then we have feature engineering. So what is feature engineering here? When we have all the features, so let's say we have timestamp, and there is a series of event, but we want to create some of the features from that raw features. So when we have timestamp, which is date and time, we can have two different features from timestamp. So one is date and one is time. Now, can we build something else with these time and date? What if we want to calculate the week of the day? whether it is Monday or Wednesday or Thursday. So we can find out the week of the day from the date. Then we have time. Time can be used for multiple features, building multiple features. Here we are building the window of the day. Let's imagine that you have 24, 24 hours in a day, right? We know that there are 24 hours in a day, but when we want to have some application which says that we want to take only let's say 5 minutes buckets or 15 minutes, every 15 minutes we want to see how the data is looking like. So we can create those windows of the day from that time feature. Then when we have multiple series of events, let's say there is, let's for example there is one event of navigation of any application. So if you're buying any product on Amazon and you want, and the system wants to find out, like your problem statement is to find out that whether the person has made the purchase or not. So to identify that particular event, so when we have all the page URLs of that application browsing of each person, we'll just go look at the payment, where the payment has been done, and see that the payment has been done and the purchase has been made. So to identify that particular event, we can have that milestone pages. We can say that the payment has been done. So there are multiple ways to do feature engineering. So these are some of the examples here. Once we have the feature engineering done, um, we will go with the data transformation. So before data transformation, I would like to add one more point here, which Priya also told, that there are data types of features. It could be continuous, it could be categorical features. So when we talk about the continuous features, it is always numerical data set. When we have the categorical features, let's say when we are defining the color or the shape of the object, then it is a categorical feature. Let's say orange, green, yellow, red, and the shape circle, triangle, and trapezoidal, and so on. So we want to transform these categorical features into continuous features because the model will always work on continuous features. So how do we transform the data? So there are multiple algorithms to transform the data from categorical to continuous. So let's say there is something called label encoding and there is something called one-hot encoding, which is widely used to convert categorical feature into continuous feature. So let's say how the model will behave when we try to give the model the categorical features, which are not the model with respect to the model format. So here we can see that when we have non-transform data, the model will fight back to us, cannot process. I accept only numerical data only. Now, when you have the transform data, the model will be happy and it will say that I can process that. That seems perfect. Alright. So let's go to the pattern learning. So now when we have the data, we have done all the pre-processing, we have done the feature engineering, we have done the transformation. Now the pattern learning comes. Now the model comes. How does the model work here? Let's say there is one example which here in this image we can see that there are multiple data points here. Now they assume that they are untagged data set. So now when we run the clustering algorithm here, what the clustering algorithm will do, it finds out one data point and it finds out this distance of that data point from different data points, and then it keeps on creating the cluster of the similar data points. Uh, well, here in the green, in the red, and the blue clusters, we can see that there are three different types of behaviors which are converted into the clusters with centroid X. So this is actually k-means algorithm. So when your this k-means algorithm is one type of clustering algorithm which has the centroid and some data points which are near to the centroid. Well, so how does the pattern learning happening here? It just takes out the similar data points and makes it as one class, and then there is something which is similar data points. Then it is red class, and this is blue class. So let's say green, blue, and red class here. So now, how do we do anomaly detection here? All right. So when we have our clusters made, then whenever the new data point comes, so let's say when this X point comes here, so we can say that it is not similar to green. This is definitely not similar to green. It is not similar to blue, and it is very far from red as well. So we will call this point as anomaly because this data point is deviation occurring in the system. Now, what about this data point? This data point is also away from green, red, and blue. So this data point will also be called as anomaly. What about this data point? This X here. Well, we can see that this data point is very much similar to the blue data points, and that is why it is a normal data point here. And again, then this data point, which is also similar to the red cluster. So now we can call it as normal data point. Now, once we have the anomaly detected from the system, how do we do? How do we take the actions? What do we do with this data point? What do we do with this data point? So one thing is, so there are two types of responses to be taken in the system. So one is reactive and one is proactive. So when you are working in with the real-time data sets, when it is very critical to have the anomalies detected on the flow. Let's say one example that there is a satellite launch from Earth, and on the fly, like on real time, when the satellite is approaching to its destination, some bug happens in the system, or there are some increase in the temperature or in the angle of projectile, anything happens. So at that time, when we find out that there is a deviation in the angle which should not happen there, and take the and tag that data point as anomaly in real time, calling that as anomaly in real time at the moment it happens, it is called as proactive action, which will happen in real time, and this data will trigger an alarm saying that there has been a deviation in the projectile of the satellite at this timestamp, at this particular location, at this temperature, and so on. So there is something called reactive approach. So when reactive approach is useful, it is useful when we have the data set with us after the event has over. Let's say that let's say I have built one model of anomaly detection, and now whenever I give a new data point to the system, it tags that data as anomaly and normal and give it back to me. But it is not the proactive approach. It is offline approach. Yeah, so here mostly the tagging is done. In proactive, mostly the trigger alarm appears. Now, when we have everything on place, we have built a model. Now, which model to go with? So, somebody has told, somebody has quoted something saying that all models are successful but with different results. So there are some models which gives you accuracy of, let's say, 47%, and there are some models will give us the accuracy of 99%. They both are successful, but they are giving us different results. Now we want to find out which model is best for our particular application. So here, this is how very high level comparison of the algorithm of the models looks like. So this is multi-class logistic regression, which has training time, which is fast, and classification accuracy is quite low. Now the multi-class neural network, it has training time as low, slow, and accuracy is high. Then again, decision is fast, so and accuracy is low. So this is this this table is not related to all the data points, data sets. It is related to this is it is just an example of one set of data set. Usually, the training time appears into the milliseconds or seconds, and classification accuracy appears in the percentage. So when we look into this table, when we compare SVM, decision jungle, boosted decision tree, decision forest, decision jungle, again multi-class decision forest, and neural networks and logistic regression. Which one should we go with? So it depends on what is your priority. Do you want the training time to be fast, because there are some huge data sets for which the training time takes multiple days. So I'll give you one example. So I was working on this data set and it took like 300 days for training time. So it's better to go for low accuracy than go for 300 days for the training time. So sometimes it is good, and when the requirement of the project is the high accuracy, then we can go with the slow training time. So this is not always the case. There are some cases when we have fast training time and fast classification accuracy as well. Well, now this is the slide. So before I started the presentation, I got the message from Banswara College that there are many students which are looking for how to start machine learning if they have not started yet. So this is the slide for some of the tutorials and the links that will help you to start with machine learning, how to start with it. So what are the prerequisites of machine learning when you want to start? You should know the statistics. Statistics is must. You should know calculus, obviously, linear algebra, probability, and you should have programming knowledge. So, what type of programming should be done for machine learning? Usually, there are two types of programmings which I am aware of people are using. One is R and one is Python. So for industrial purpose, we are using Python language because sometimes our language is not uh, very efficient. So our language is usually used for data analysis purpose, and for modeling purpose we use Python because it is faster And when we are working on GPUs and high-end servers, then Python is most likely to be used. And then statistics. So statistics is very important prerequisite before starting machine learning. And if you have some language of statistics, you can go with machine learning, and then on the parallel you can start reading statistics as well as machine learning. So this is one of the channels, StatQuest with Josh Starmer. This is StatQuest. So here, this is the best for machine this statistics if you are looking for. So I usually watch Josh Starmer, StatQuest. So he is very good in statistics tutorials. Then there is machine learning from beginners to advanced with hands-on. There is this one course on Udemy. This is the paid course. You might get a discount during this COVID situation, maybe. I think this course is 600 or 1200 rupees only. Then we have Neptel pattern recognition, PK Viswas. So this Neptel pattern recognition by PK Viswas is I found it very useful for my coursework when I was giving this exam. This was very useful, and you will have one idea to visualize the data in multi-dimensional space. Then you have this EDX, Machine Learning Fundamental course on EDX by Sanjoy Dasgupta from UC San Diego University. And then there is one more course on EDX by John W. Paisley from Columbia University. And if you want to learn Python, there is something called Data Camp. This is a website as well as a YouTube channel where you can learn Python from Data Camp. So there are apart from this, there are many courses available which are unpaid and paid both. You can go for Coursera is one of the website, and then there are some websites if you want to read about it. There is something called Analytics Vidya. There is something called Towards Data Science, which I have not included here. So you can go and read there, and there are multiple GitHub links. There you can just go read and implement the code, and you will be able to learn machine learning. So one main point here is to visualize the data in multidimensional space is the biggest necessity of machine learning. So once you know how the data looks in multidimensional space, you are good to go. Now I have this is a hands-on session which says some anomaly detection example, classification example on iris dataset. So here we have so what is iris? So iris is a flower which has multiple species, which is versicolor, setosa, and virginica, and they are different in the shape and the size of the leaf. So the length of the leaf, so here we can see this is the petal and this is the sepal. So the length and width of the petal and length and width of the sepal differentiates each of the species of iris dataset. So this is the very basic example dataset which you will find everywhere to understand the classification model anywhere. So if you have not seen how the data looks like, so this is how the data looks like. It has some continuous features list, and these are the values. the length, width, and the length and width of petal and sepal, and these are the species. So when I was talking about when I was talking about the supervised learning, the tags where I mentioned is this tag. So when we have species like species which says us that this is Setosa species, when this is the feature instances values, this is the species. This is the species name for these all values, and this is the species name for all these values. So this is when we have the species name. When we have this column missing, forget this column is there. When we don't have this column here, it becomes unsupervised learning. So when we do not have the tag data and we have only the feature list of the dataset. Also, when I mentioned about the feature pre-processing, I just go back here. When I was talking about this feature pre-processing, so we know that there are some data points which are categorical, some are continuous, and there are some timestamp features. So usually what happens when you are reading a file from your repository to your Python file, you have to give the data type yourself. Like you have to give the data type yourself to the feature, because sometimes it detects timestamp as string. So you have to specify that this is the timestamp and I want the data type to be timestamp. Yeah. All right. So yeah. All right. So now let's go with the Python demo. I'll just start sharing another screen. Let me know when it is visible to you. Is it visible? Shubham, can you tell me?
Well, your presentation screen is visible currently.
Oh, okay. I'm sharing one notebook file. Just 1 minute. I'll stop sharing and reshare again. Just 1 minute.
Sure, ma'am.
All right. Is it visible?
Yes, ma'am. It is Jupyter Notebook. It is visible.
Yes, yes. Fine. So we have 30 minutes more, right? 30 more minutes. So I think
Yeah,
we'll.
you have your time. Take your time.
Okay, okay. So I was thinking I'll take all the time, but I think I'll be able to complete earlier, and then we'll have more window for Q&A session. All right. So this is one iris dataset here, and now that we have time, I'll explain each and every line to you. So this is okay. So first of all, I'll tell you what is this window we are looking at. So this is called as Jupyter Notebook, where you can go ahead and create a Python file, and you can do all these things here and so on. So for this Python, you need to have some environment of Anaconda. So if you go and search for Anaconda, you will have the system in your room and install it. So I prefer to install, like when you are working with small dataset, go with the Windows. When you're working with larger datasets and there are some libraries which are not supported by Windows, go with Linux. So when I was working on some data set which did not support parallel programming and it was taking some 300 days time, I went with Linux, and there was some library which was available only for Linux for parallel programming. So in Linux, I was able to do in 18 hours. So yeah, all right. So these are the libraries. These are very basic libraries. Here we have sklearn libraries. So sklearn is usually used for modeling purpose. All the models are there. Then we have pandas library. So when we want to read a data set and we want to see the data set like this, so we use pandas library for reading and writing the data set and perform the operations, creating the features for any file. So mostly we use pandas. There are alternative libraries to it also. I have not used them. Then we have again sklearn has train test split and tree and accuracy score. So we'll be using it later. I'll explain to you later in next upcoming sense. This library NumPy here is useful when we are working on the array and matrix. So when I showed you the CSV file, the data set, how it looked for iris data set. So here, this PD is taken from pandas SPD because we are reading a CSV file here, which is iris CSV file. This is how we read a file, pd.read CSV, iris.csv. And I am reading it into a DF. DF is data frame usually. So you can have anything here, A, B, C or anything. So no need to, if somebody is noting it down, no need to note it down. I'll send it to Himanshu or Shubham, HOD in college, and then they will, whenever they will upload it anywhere, you will have the link, the GitHub link, or the everything will be available there. You just have to look here. Then this DF info. So now, okay, I'll just run it. So I'm using Shift plus Enter key to run each cell here. So now when this is run, so DF has the value from CSV, and when I run this df.info, how does it look? So let me. Clear up. Okay. So it says that here it says that the range index, it says there are 150 entries 0 to 149 and there are 5 columns. So it says that there are 150 rows and there are 5 columns. So what are those 5 columns here? It is sepal length, sepal width, petal length and petal width, and each of them has 150 non-null values. So if there is any, when I say that, when I gave you example of fruits, that lychee with the leaves or mango with the leaves, so or any fruit without leaves, so the leaves will have null values for some of the fruits. So here, when we run that data set, it will not say non-null. It will say there are some null values here. And then we have the data types. So all of them, we know that they all are float values. And then species. Species is categorical feature here, which says Virginica, Setosa, and versicolor. So we have these object. Object is categorical feature here. So now when I write tf.describe, it gives us the count, the mean, standard deviation, minimum, maximum, and all the percentage, 25, 50, and 75% data at what is the data value at this percentile value. Then this is something called value count feature, which tells us that what is the count of the values in species. So it says there are 50 Setosa, 50 versicolor, 50 virginica. So let's say if I write, so because it is numerical feature, let's say if I write sepal length dot value counts, it gives us all the values. It will give us like 6.3, there are 9 6.3s, there are 9 1 5.1, and so on. And there is 1 7.1. So it gives us all the values and its count. So now this is how the data frame looks like. So it says, so this is, if you read a CSV in Excel file, the same, you can see the same similar view. So now what we are doing here. So now we want to visualize the data points that, as I told you, like the main the main prerequisite of having to start with machine learning is to visualize the data set in multidimensional space. So here we are looking into two-dimensional space, which says that the sepal length versus petal length, and each of the data point here from this DF has been plotted here, which took only length. So it took only sepal length and petal length and sepal length of all the species. And all right, so here we are plotting a scatter plot, and the hue hue means like the color of how do we differentiate the color in the plot. So here hue is Setosa, versicolor, and virginica. These are the three species of iris flower. So we can see here that there are, the Setosa has sepal length and petal length, which is very different from virginica and versicolor. But there are some data points from versicolor and virginica which are similar to each other. Here in this region we can see. Also, I'll explain these libraries. So this library, matplotlib.pyplot library. So this, if you have worked on MATLAB, so this is similar to it. It is actually MATLAB library for Python, which helps us to plot things. And there is something called Seaborn. Seaborn is also used for plotting, and it has many different functions which matplotlib does not have. So here we have the length, few, and here we have the width clustering. So here also we can see that Setosa width, petal and sepal width is still different from virginica and versicolor, and there are some data points in versicolor and virginica which are similar to each other. Okay. So now what are we doing? Now how do we do the anomaly analysis here? So what are we doing here? So I have taken here as just one minute. Okay. So what are we doing? We are creating one more column here. So we have something like this. We are creating one more column here which says that 0 or 1, and where 1 means anomaly and 0 means normal. So how do we do this? So first we want to have two classes. So what we are doing here, we are considering this cluster here as normal and this cluster here as anomaly. So what I have done, NP where is the condition, and DF species, if the species is virginica or is the condition, or versicolor, then when this condition is true, it makes 0, it returns 0, and if its condition is false, it returns 1. So if it returns 0, where this 0 and 1 will go, this will go in the new column called class NDF here. So, all right. So when we run this, and we can run here again. So, all right, just 1 minute. So I'll show you how our DF looked earlier and how our DF looks afterwards. So this is how our DF looked earlier, and when I added a class here, this is how it looks. So, okay. Sample. So what is the difference between head and sample? So head gives only the first few rows, and sample gives any random rows. Here we can see that when the species is Virginica or versicolor, the class label is 0, and when it is Setosa, it is the class label is 1, anomaly. Now, again, now when we have only two classes and we plot again with two classes, only with orange and blue, we have the view like this with the length and width. Again, we want to find out what is the class value counts. So there are 100 data points here, this blue part, which are 0, which are normal in our case, and there are 50 data points, this orange one, which are 1, which is anomaly in our case. So now there is something called train and test splitting. So whenever we have a data set, we have to have a train and test data set and validation data set. So whenever there is a model, we should have some data set to train it, right? And then once the model has been trained, we have some set of data. There is a chunk of the whole data set divided into test and train. Train being the bigger part, say 80%, and test being the smaller part, 20%, which the test data is run on the model to test whether the model is performing good or bad. Like what is the accuracy and what is the precision recall of the model to test the model metrics. So we call it the metrics. Right. So now, when here what we are doing, we have X train, X test, a Y train, Y test. So Y, I'm using X and Y here. So in training, when we want to train the data set, we want to give the labels in different column and the rest of the data set in different column. So what we are doing, so the bigger part, the feature part is called as X, and the tagging part, the label part is called as Y. So we are splitting the data set into 80 and 20% with using this function here, train test split. And for the X part, we are dropping the species and classes, class column, and when we are working with Y part, we are only considering the class column here. So when this is how the DF looks, and after splitting, X train looks like this. So X train has all these columns and these values, and X test also looks like this, but it has the less number of columns, less number of rows, the records. And this is how the train Y part of the train and test looks like. 0, 0, 0, 1, 0, and 1, 0, 1, 0, and so on. And so if we want to see, sorry, a minute. Okay, so if we want to see that what is the shape of X train and X test. and the approximate shape. So here we can see that after dividing 150 into 80 and 20, we have 80% value, which is 120 in train and 30 records in test. And why it has 6 columns? Because we have removed 2 columns, species and class, from the total from the data set here. Species and class we have removed, so that is why there are only 4 columns here. All right. So now, okay. So now this is the model part. So you can see that this model part is only three line code. But to understand this model, so in machine learning, it is not important that you can code like this. You have to understand what is going behind this code. Okay. So see, it just took a moment for me to run it. So what I'm doing here, I'm using the decision tree classification model in this. So what I'm doing here, tree dot classifier, and then I fit the model. So whenever this is the object, so I do dt dot fit x train and y train, and then I do dt prediction of what? Like I want to store prediction in this. It is dt dot predict. So dt is the object of this tree class and decision tree classifier function. And I'm predicting the x test on this dd. So, and then I find out what is the accuracy of this model. So this is 100% accuracy. You can see. Now, the same thing, because this is not the only model we are using. We are going to use logistic regression model also. I think Priya explained this in the earlier session about the house cost and the rooms and so on. Okay, so here we are importing logistic regression from sklearn linear model, and then again we are creating similar way. We are creating this object and fitting the model in our object with our LR object, and then we are predicting on X test. So here again we can see the accuracy is 100% here because we have very small data set. So now we can see the test head. This is how it looks. Now, okay. So here is the important part. So what goes in LR prediction and DT predictions? So it returns a list of tags associated with this X test. So here we can compare this. So this is the X test dot head. So this with this record, when DT has predicted that this is an anomaly. For this particular record, DT has said that this is normal, and for this decision tree has seen anomaly, and then so on and normal. So this X test is mapped with this list. This is the decision tree list, and this one is logistic regression prediction list. So here we can see they both are giving the same results because the accuracy is 100%, and we have a very small data set. So here the results are not very idle because this is not the case in real time, real life data set, and it should not be. So here we can see. Okay, so. Here we can see there are 30 records which went into X test, and there are 30 predictions and so on for LR and DT. Now, when there is something called as confusion matrix. So it tells us how many data points are correctly classified in which class. So there are 2 classes, 0 and 1, and how many data points are associated with which classes. So let's look here. This is the confusion matrix for DT here. Just one minute. It should be DT here. Okay. Doesn't matter, it gives the same result. Okay. What does it say? That there are 22 results in zero class, which is normal class, and there are 8 results in, so it is 22 plus 0 and 0 plus 8 results in one class. And out of 22, all 22 records were correctly classified and 0 records were misclassified as class 0. And here we can see that out of 8 records, 0 records has been incorrectly classified as class 1 here. So this is the confusion matrix looks like. So when you go deeper into learning and modeling, you will have a clear idea of this metric. So actually, the idea to show this metric is, when you run the model, it is not enough to find out the accuracy. This accuracy is not enough. So what all things we have to look into? We have to look into precision, recall, F1 score, and support for both the classes 0 and 1, and the confusion matrix associated with it. So because again we have smaller data set, everything is 100% here for decision tree, and I think this will be the same case with logistic regression as well. Yes. Again, we can see that it is also 100% here. So it should not see whenever precision, recall, accuracy, everything is 100%. The model is overfit, and we do not want the model to be overfit. So it is. I'll just write it down. What I'm trying, overfit. So this should not be the case. Should not be the case. Then we have a test again. Just to look here, not required. Okay. This is also not required. Now, okay. Now we want to. So this is group by an aggregate function. You might be. This is very useful function, group by function. So here we can see for class 0, what is the minimum and maximum value for each of the feature. So sepal length, what is the minimum and maximum, what is sepal width, minimum and maximum, and so on. And species, and okay. So this is alphabetical wise, so we don't have to go with this. So yeah, so in pre-processing, you might have to look into this thing, and then the standard deviation, which I showed here. Here, the count, mean, standard deviation. So these are the very basics of looking and understanding the data. So when I say, do you understand your data? It is very, very important to understand your data, because the goal of the application or your problem statement is depending on your data set. So now, okay, so what I'm doing here, once we have the trained model, we have tested and created the prediction list here. So now we want to create our own data points and feed into the model and see how it reacts. So what I've done here, I have just created a random, this is random data frame from which has the range of 0 to 9, and it is of size 25 into 4, and which has columns like this. So when I say the range 0 to 9, it takes actually the value from 0 to 8, and it will give us this value because they are integer values. Now we have, this is how the X sample data looks like. Now what we are doing here in this step, we are using the decision tree model and predicting on sample X, and let's say what y it gives us, what are the labels it gives us, and then we create one more function called class here, and then we have one more column along with all these data points. So now let's look how the data looks like now. Okay. So when we feed the new model to our new data points to our pre-trained model and predicted the labels using decision trees, this is the results we are getting for this sample data. So here we can see that the points 1 are anomaly here and zeros are normal. And here we can see again in the width, these are anomalies and these are normals. And again, when we are doing this with logistic regression, this is the data frame. And so what we are doing here, we are creating the class which feeds logistic regression dot predict dot sample data x, which does not have the class column in this. So now when we look into the results provided by logistic regression here, and when we compare it with the results which decision tree gave. So let's say into the sepal width and petal width, 1, 2, 3 data points are anomaly in this this is a set of data points. And here we can see in logistic regression there are 1, 2, 3, 4 and 5 and 6. There are 6 data points which are anomalous in this data set. So this is to show you that same data set, different models will give you different results with the same data set. So yeah. So this ends our session here. So yeah. All right. So I'll again share my screen here. And if you want to, if you have any questions, you can ask. And if you want to contact me, you can contact me on my LinkedIn page and you can message me anytime. I'll be available for answering your questions.
Okay, thank you, Akanksha ma'am, for sharing such a wonderful insight about machine learning and application as well as the practical demonstration of the same field. And as per the previous questions we received during the registration, I from one of the participant. Yeah, ma'am. Is it audible?
Yes, audible. Yes.
So I have one query from the one of the student that uh, a person can start their own startup, or if any person is looking for the startup in machine learning area, so how that person can proceed or go ahead? Any suggestion for that person?
Yes, totally. You can go with the machine learning startup. Actually, I worked in a startup in machine learning also. So you are asking like what could be the what was the question again?
Yeah, means a person if we want to set up a kind of startup related to machine learning area. So what are the skills or what are the model of friendly which the person had to set up? Yeah.
Okay. So first of all, the person should have the knowledge of the business. What problems are they going to uh, they're going to strike? Like whether they are going to give the AI solutions to the other companies, or they want to build a product or something. So
Okay.
they should have product knowledge, and then yes, they should obviously know the machine learning part, like how you can uh, hit a problem. Yes.
Okay. Okay. Thank you. And remaining, I hope most of the questions you have covered during your presentation, like what are the prerequisites of the ML and
Yes.
how basic require what are the basic requirement of machine learning that you have covered very nicely. So on behalf of whole Engineering College Banswara fraternity, I would like to thank you, Akanksha ma'am, for sharing your expertise with us. And thank you all the participants for your patience listening. The feedback link is already circulated in the chat box. And if you or one of your friend has been missed this session, then they can go to our college YouTube channel to revisit the same content. They can go through. And thank you so much to all. You all will get your certificate just after submitting your feedback form within 2 to 3 days. Thank you, ma'am. Thank you, ma'am. Thank you, all the participants. That's all
Thank you.
about from this. Yeah, ma'am.
Yeah, thank you. Thanks a
Yeah,
lot.
thank you so much. Yeah.